soil sample, when it comes to laboratory, should fully represent the area that it has been taken from. In a hectare land, in 1 hectare, you need 2 soil samples that will represent that area. And that's also, it's crucial to note that when you take your soil sample, you must make sure you only take a soil sample up to 20 meters, or what we call the root level. And when you take your soil sample as well, make sure you remove all the debris at the top. Because that debris at the top, when you analyze, it now becomes organic matter. What we'll be doing now, we'll be saying your soil is full of organic matter, which won't be true. So you remove all the top part of the soil, and then you take your sample up to root level. And all these things that we use now for when we are taking soil, which we are going to demonstrate, should be clean. The reason is, Craig, if you take your utensils and you don't clean them, in the laboratory we're going to pick so many things from those utensils. We pick phosphate, we pick calcium, which is actually from your hoe, or from your shovel, or from your auger, or from your bucket. So make sure all these things are clean.
Including the packet where you're going to put it.
Including the packet that we are going to put it. You make sure they are clean. Everything is clean, it's washed up. But the laboratory is going to pick everything that is in the soil. So that soil sample is very crucial. That's why also the method of sampling is crucial. Like we're going to demonstrate now how to take that soil sample. In a field, people have got so many ways of taking samples. Some use what we call zigzag, a pattern, where they take from this corner, that corner, that corner, that corner, that corner. Some take both corners, 4 corners, and they take in the middle. Some actually take randomly, but as long as it is representative, then you put in a bucket or you put somewhere, then you mix your sample, then you extract your 1 kg. That will actually come to the laboratory. As you specifically said, you don't take your samples like from any end to, the reason being, or from where there's cow dung, because once you take the properties of the N2 will actually reflect on the result. Now it appears now like the whole of your field is an N2. If you take where there's cow dung, it now feels like we have taken a sample from a crow. Mm-hmm. It's not a crow.
Yes,
it's a soil.
It's just
so this is why we avoid that. So all these avoidance are critical, because we in the laboratory now, when we pick whatever you pick, it now comes to your recommendation. So we'll be recommending falsely what is not in your soil. So let me give an example of how we can take a soil sample. We have a shovel where we remove all the debris at the top first.
Yeah, well, if you look at it, if you look at it from the way you're saying it,
yes.
Because if you look at all these, already they've decayed,
yes,
and it's manure on their own.
That's right.
So as a result, yeah, I understand what you're saying.
You understand what I'm saying now?
Yes,
yeah.
yes.
So I want to actually to get what is in the soil. The properties, also there's bacteria there, which is also good for it. It breaks also down the soil, and also what is decaying is also part of the soil. It's going to aid our humus, which, as you know pretty well, that if our organic matter is there, it balances the soil. It acts like a buffer.
In summary, from what Mr. Bakke is saying, assuming this is our piece of land, right, we have to avoid the edges of a field at least 2 meters going in. So in other words, we don't have to really mark our field, but we avoid this part here, which is around the field. And then we look at the piece of land to see if there are any swamp areas, if there are any waterlogging areas, if there are any areas with ant hills, or if there are any lines which had a crop or that. So we avoid these lines here, or the rows, we avoid the ant hills, we avoid all those places. And then from what you were saying, you was talking of a zigzag, right? To say this is half a hectare, and then we can probably maybe put our zigzag there, and then we do samples 1, 2, 3, 4, 5, 6, 7, 8, probably 9. And then these are the samples using the same method which has shown us here. And then out of that, we have our probably 9, 10 samples in a bucket which we properly mix, and after mixing, we collect 1 sample which now goes to the lab. So Mr. Bakke is going to show us how actually we mix the soil and we extract the sample out of it.
as you can see, Craig right now is making sure we get a proper soil sample where after what he is doing right now, if there are any loose stones in there, he's going to throw them away. If there's any debris that is there, he's throwing it away. What we need is the fine soil. That is what carries our nutrients in the soil. So anything other than that, we throw away. So that is exactly what he's doing right now, before we actually do the mixing of a sample. And we are going to go through that routine when he finishes what he's doing right now, which is removing all the loose stones, as you can see, removing all the debris that is there, as you can see. What will be left is the fine soil that we need, the fine soil that carries all the nutrition that the plant needs. This is where you do your proper mixing. In every stage, we are trying to say we don't want any contamination in this soil sample. So even that we are using, whatever is testing, is also clean. Even the scoop that we're going to use or a trowel that we're going to use for mixing should be clean. As we demonstrate now, the way we're going to mix it, now the soil is being mixed. You can see the portions are being taken all over to make sure that we have a properly mixed sample. As you know, soil is not homogeneous like water. These are particles that we have to mix. And we are trying to do the best that we can. But not all the particles from the portions that we have taken are properly mixed. If we are improvising right now, this is not a scoop. We could use a trowel, we could use a scoop, we could use anything that can carry like that thing. And that scoop that he's using, if it's a scoop, if it's a trowel, soil must be cleaned as well. As he's demonstrating now how to mix the soil. He puts that on the other side and then he mix on reversing to the other side before he take our representative sample to the laboratory and we pack it in this package that we have after the mixing. The mixing is actually, we are now going into the last part of taking our soil sample.
So we've done once. How many times do we?
We do it second time again.
We do it second time?
Yes. And the second time, as you see, the soil is rolling over on top of each other. As I told you, these are grains and they are particles. We are now sure that they've rolled over and most of them are mixed up to the best that we can, because we are trying to do the best that we can, that we truly have a representative sample. That when it goes into the laboratory and the results come out, we truly reflect the nutritional status of the soil there, and the farmer will get the best result in the laboratory.
So how many kgs do you take now? We've got a full bucket there.
Of course, if we start taking 10 kgs from the soil, the whole field will end up in the laboratory. We only take half a kg.
All right.
That is taken in for the you can scoop just half a kg.
Half a kg, would I say?
Yeah.
Now we can just take.
Yeah, now we can just take the.
Okay.
Yeah.
Would this be a half a kg?
That would be half a kg. Now this is our sample that has been taken.
All right.
And now we've written our name is block 1, and now this sample now goes to the laboratory for testing.
I've attended so many field days with Mr. Bake, and one thing he stresses to the farmer is farming starts in the lab. Can you explain more?
Exactly. Farmers do a shortcut of starting the farming elsewhere. Farming starts in the laboratory because this is now where you get all the information that you need. And it might surprise you, even for your banks, they need this information. If you want to get
applying for a loan.
Yes, if you want to apply money in the bank, you have your soil tested like this, then the agronomist now will certainly put a recommendation there, how many bags of feeders that you want to plant. And you go to the seed people, they give you the plant population, so you know how many bags of seed that you want. And after that, the agronomist will give you what they call an expected yield. After you've done all these things, we expect a minimum of so much. And then with the hectares that you have now, you add that up, you go to the banker. The banker will say, let's see, Mr. X, what do you have? Said, I did my soil test and my agronomist recommended this, and my people from the agro-business recommended that I buy so much seed, I buy so much fertilizer. And the agronomist said, the minimum we can get is this. And the banker will see the minimum and says, oh yes, by then we'd have paid up already on your minimum. Yeah. We're just saying the minimum that is expected, not the maximum.
Yes.
So the maximum is actually the profit of the farmer. Once he does it like this, look, we don't want a farmer who goes there not knowing where he's going. Once you do this, then a farmer knows exactly where he's going, exactly what he must reap. That's what we think. And this now becomes our professional farmer. We encourage every farmer that please don't break the circuit. As you know, those people who play with electricity, once you break the circuit, you know what happens? There's an explosion.
Right.
So farmers are creating explosions by not coming first to the laboratory. Farming starts in the lab.
In the lab.
Why? We want to know what happened last year. We want to know what happened the previous year. We want to know what to apply. We want to know what is there in the soil. We want to know what is toxic, what is deficient.
Right.
So that can only be determined once we do a soil testing. I think from now on, the farmers won't break the circuit.
Right.
Because you cause explosions in the farms.
Thank you
so much.
Thank you so much.
Okay.
All right.